Everyone. My name is Dia Alcott, and I am a mechanical engineer. And in my daily work, I develop software for mechanical engineering applications, namely applications for measuring physical objects using hybrid approaches of 3D geometric modeling and grayscale image analysis. My goal from today is to introduce to you what I have been learning about applying local language models and developing using them. And the focus will be on the Gemma 4 models for reasons to be explained later. First things first, I would like to acknowledge very kindly the help and great support of Ali, Aronesh Chowdhury, and Joe Youssef. They gave me excellent critique, and hopefully, with their critique, this presentation will be a little less boring. And if you don't mind, I added this QR code, which will take you to a Google Drive folder that I made public, where I placed all the presentation materials that I'm going to present today. So this presentation is there, the code samples are there, and some supplementary materials I generated using AI are there. So if you can take a few seconds to make sure this QR code works, that would be fantastic. And maybe we can get back to it later at the end of the presentation if that works. So in the core of any large language model exists an artificial neural network. And an artificial neural network basically is just a set of small computing devices that we refer to in the AI lingo as nodes. And these nodes are connected to the nodes on every layer of the neural network are connected to every other node on the next layer, and so on. And whatever input that we give to the language model, any question we send to it, anything we wanted to parse and make sense of, passes through these nodes. It's analyzed, passes through these nodes, and in the end, we get a result. The words during the training process of every of the large language model, which consumes a lot of data, the internet, news, etc., etc. Wikipedia, for example, every word that is passed to the language model during its training process is represented within the language model using a set of coordinates. And the set of coordinates are known as vectors. So each token referring to a word would have a representation in an n space. And that n space, think of it, let's take the analogy of, say, representing a 3D point in space. You have the x, y, and z coordinates. In the AI world, each word could have between, say, 2048 coordinates to 9,000 plus coordinates in really, really large language models. And the way the language model works is by predicting the next word. So you give it a word and it predicts what can come next based on how close in that huge coordinate space the other words to it. So it finds the closest node or token to any token that you add to it. So let's take, for example, this prompt in which we would ask the language model to find who is the traitor in the Godfather movie who would approach Michael Corleone to set up a meeting with Barzini where Michael is going to be assassinated. In orange there, you see some key tokens which as soon as they are passed to the algorithm within the the language model, the coordinate for each one of these key points is taken, and the language model searches within the vicinity of every token to find at the very end that the traitor was cell tissue, and he meets his demise because of being a traitor to the Corleone family. So this is just to show you that the database, that the language model is not a database. It's not that the language model, Gemini or what have you, will go to the table, the movies table, and find the Godfather column. Row, and then find or document and find this information. It basically predicts what comes next. It's a map, in other words. So long time ago in ancient history, and when I say ancient history, I mean like 3-4 years ago, in perspective, it was the only way we could access AI is through cloud access. And accessing it through the cloud meant communicating via the internet or through the internet with huge data centers that are the sizes of little villages, to send our questions and get our answers. As technology progressed, it became possible now to access language models, albeit smaller language models. They are smaller than, say, Gemini or the Anthropic language models or the GPT models. They are smaller, but they are possible to access on local devices. We can install them on phones, on laptops, Raspberry Pis, or embed them in chips. So they would be small, but they can be helpful. And this reminds me of a saying that you don't need a chainsaw to carve a turkey, do you? You use the right tool for the right task. So in our case here, in the local or edge AI case, we can use them to perform smaller tasks, but tasks that may be enough for our needs, for our daily purposes, like writing a proper email, translating a word, etc., etc. We don't really have to use the chainsaw to do that. We can use the automated knife to do that. So this will be the topic today, how to deal with local models and how to program them. So why local models in general, and specifically why the Gemma 4 family of models? The Gemma 4 in particular provides us, and this applies to other models as well, that come from different vendors. It became a a bandwagon that everybody jumped upon to get a piece of this growing market. So local AI models give us total privacy. So if your application involves the need to not send any data to the cloud, maybe you have patient data that you don't want or cannot and should not send to the cloud, then local AI is your tool of choice. If you want to build an application that can handle patient data, for example, or financial data, or any sort of data that you don't want to leak to the cloud. Secondly, local models provide us with an almost zero cost. And the reason why I'm saying almost is because you still pay for the energy used to run the local model. But thinking of energy, it's not the energy of a huge data center, the chainsaw. It's the energy used to power a laptop or a Raspberry Pi or a phone. So there is a significant difference between the two. Thirdly, and this is specific to the Gemma 4, and this is to the best of my knowledge, Gemma 4 models, the local models, come with an Apache 2.0 license, which means you have totally unrestricted utilization for these models. You can use them for personal usages, for commercial purposes. You can build an application and embed them in them, and Google, absolutely nothing. This is to the best of my knowledge, and I don't know if other vendors have similar licenses. I know that some may come with another permissive license, which is the MIT, but I have been experimenting mostly with the Gemma 4 models. Here's a reality check. As mentioned before, more parameters in a model, like 700 billion parameters in the frontier models, Gemini and what have you, mean more dimensions. So instead of representing every token as 2000 in 2000 coordinate, these huge models that run on the big data centers may represent them in 9,000 plus parameters, for example, which means that we get deeper reasoning using the huge models and less deeper reasoning using the smaller models. So there is a little bit of a trade-off. And as you could predict, the trade-off here is less deeper reasoning for the smaller models, but much more power efficiency and the privacy and the free utilization and so on. Another concept is quantization, which basically is rounding the values of the aforementioned coordinates within the representation of every token within the model. And with this rounding comes saving in memory usage, because we would have to load the whole model into the memory and keep it into the memory. When we quantize a model, we reduce greatly the amount of RAM, video RAM needed for running it. But at the same time, we also lose a little bit of the accuracy in the reasoning. And again, it's a trade-off. So it all depends on the application. And the sweet spot typically would be to use a quantized large model, or the quantized version of a large model over a smaller version of a model. So for example, if I have Gemma 4 2 billion parameters, it probably be better to use, it would be actually better to use the quantized version of the 31 billion Gemma 4 version than to use that 2 billion parameter model. Nothing should stop us from having a hybrid approach if we can. So for example, if I have smaller tasks to run on a daily basis, I could use the smaller local model to do them. And if I have huge tasks for which I have to have access to cloud model, then maybe I should save a little bit of money and use the smaller model for the smaller tasks, the free model, the private model, and the larger model for more difficult tasks. Now I would like to start working or start demonstrating to you some of what I've been talking about. So what I'm going to do is show you how we connect with local AI using Olama. And Olama is one of the tools that we can use to access local language models or cloud language models for that matter, some of them. And it's one of the platforms that are available for us to use. There are several others, but again, all of my experience has been with Olama. So I'll show you what Olama is about and how to load and how to chat with models. And then we will go through a quick demo of how to build small Python programs using local language models. And thirdly, I'm going to demonstrate to you some ideas, and I have a little grand finale for you to show at the end. So there are two modes to run Olama. But before we go to the modes, maybe I should show you the Olama website. So you get the Olama website from olama.com. So if you go to olama.com, you will be able to download Olama, and you will be able to browse the models that are available within Olama. And there are, I don't know how many there are, but there are many. So let's focus on Gemma 4. And if we pick Gemma 4, you will see here, and you will find that in any, when you browse to any large language model page on the Olama website, you'll see what it can be used for and the different models that are available. In addition to that, you will see the applications that you can use to access these language models, and you will see the models themselves. And this little tool here is to copy the model name to be able to pull it within Olama, as I'm going to show you shortly. Okay, and some explanation of what Gemma 4 is, and the different models and what they do, and help, etc., etc., etc. So this is a very helpful website, and it's going to be your friend, your best friend, actually, as you work with language models. Okay. What I would like to show you here is my favorite mode in working with Olama, which is the CLI mode, the command line interface. And I had already installed it, and I wouldn't waste your time with showing you how to download and all that stuff. I'm sure you'll be able to do that on your own. But when you have installed Olama, you can call it, and with this command, you can see all the different possibilities that you can access using Olama, all the different commands, all the different Olama commands. I'm going to show you our first point, which is to list the available language models on this system, on your local system. So I downloaded a few, and here you can see the size of each of these models. And for the sake of our presentations, I'm going to demonstrate to you the utilization of a 2 billion parameter model, which is a smaller model that takes 7 gigabytes to load into the RAM, at least 7 gigabytes, and the 31 billion parameter, which is a bigger hammer or a bigger knife. Although it's not a chainsaw, the chainsaw is Gemini, the big frontier model. So I have this for the 31 billion parameter, and I have this other tab to run the small parameter. So I'm going to say Olama run Gemma 4 E2B. So it's 2 billion, the 2 billion parameter model. And this period of time is what Olama takes to load the model into the memory. And in here, what I would like to show you is another command that shows us the active models in the memory. And what we see here is that our active model is the 2 billion parameters model. Its size is 7.2 gigabytes, and it's running 100% in the GPU of this machine I'm using, which means that it will give me the best possible performance, because it's completely loaded in the GPU. If I loaded a model that exceeded the available GPU RAM size, it's going to quote unquote overflow into the regular RAM. And on Linux and Windows machines, the regular RAM will be much, much, much slower than the GPU RAM that we call VRAM, and that will significantly hinder the performance of the model. So we've loaded this small model, and let's give it some questions. So we're going to ask it this first question that I showed in the presentation about who is the traitor that within the Corleone crime family. You can see it here, thinking, and you probably notice how fast it is. And this speed is always expressed in the AI world as token per second. So how many words, approximately, roughly, words does it type per second? And you can see that it's really fast because it is small. But let's look at its answer. This question touches upon the complex web of betrayal and maneuvering, and it's gone poetic about the solution, about that mystery, and it didn't tell us anything. It was fast, but it didn't tell us much, if any, about what happened. So remember this, okay? Now I'm going to ask it another question, which is also from the Godfather. I wanted to complete a particular sentence from the Godfather. Again, it's going to think very quickly, and it says, "Okay, keep your friends close and your enemies at arm's length." And this is totally wrong. It really didn't get it. Now let's look at the model with the larger uh, uh, artificial neural network within it. So I'm going to load the Gemma for 31B, 31 billion parameters. Oop. Sorry. Again, you see it's going to take a little bit longer to load the model into the memory, but it's loaded it already. And here I can run the Olama PS, and I will find that Gemma 2 billion parameter was unloaded because it has not been used for some time, and Gemma 431 parameters, 31 billion parameters has been loaded. And if you look at the activity monitor of this machine, you see here the memory consumption. So I have a total of 48 gigabytes of RAM, unified RAM, that can be used for either the GPU or the CPU. And currently the memory used is 43. So I'm really pushing it. Maybe I should be using a quantized version of that model first, but for the purpose of this presentation, this is going to work. So now let's ask the same question of the of our 31 billion parameter model, and please notice the speed with which it works. So you notice that the speed is a little bit slower, actually noticeably slower than the 2 billion parameter model, but the analysis is spot on. And yes, this was the phrase in the Godfather movie: keep your friends close and your enemies closer. For the Godfather, he kept them closer so he can assassinate them later on. Now let's ask it the question about the mystery of who was the traitor that in the Corleone family. So we ask the question and look at the model thinking. The gray lettering is for the thinking process. It says here thinking. So it's thinking about the plot. It's doing the stuff that we mentioned in the second slide of the presentation. It's looking through every important token and finding the closest tokens to it. And here it found Sal Tessio, who meets his terrible demise in the movie. Just for fun, and because of we are in the World Cup time, I thought I'd asked Gemma to And by the way, as soon as I ask Gemma to a question, Olama is going to load it into the memory. Which symphony did Beethoven dedicate to Cristiano Ronaldo? And I intentionally called him Chris to see if it will find out that Chris Ronaldo is Cristiano Ronaldo. So Gemma 2 is going about, went about, its analysis, and it found that it was Cristiano Ronaldo, but it says there is no unknown symphony by Beethoven that he dedicated to Cristiano Ronaldo. So Beethoven, who lived 200 plus years ago, there is no evidence that he dedicated any of his symphonies to Ronaldo. Now let's ask the bigger model, the 31 billion parameters model, and see what it will do. So you can see here that it's saying, hey, Beethoven lived between 1770 and 1827, and Cristiano Ronaldo, who's a footballer, was born in 1985, and its answer is spot on. Beethoven did not dedicate any symphony to Cristiano Ronaldo because he lived hundreds of years, 100 years, 150 years before Ronaldo. So how could he have dedicated a symphony to him? And again, you see the memory consumption in order for us to achieve this excellent result. Now the question is, and I can hear you guys thinking, okay, so what is the point of using the 2 billion parameter local model? Is it useless? Absolutely not. It's not useless at all, because maybe it is lacking on performing such thorough analysis on different contexts, but it can be extremely helpful in other ways. And at this point, I would like to move to the second part of our presentations, which is how to build AI models. And in building AI models, I decided to create for you 5 examples. And all 5 examples are using the smaller Gemma 4 model, that 2 billion parameters model, just to show you that, yeah, it may not be very useful in some situations, but in other situations, it's extremely capable. And again, the question becomes, and especially for those of you who would be interested in the hackathon that's going to be announced tomorrow, what to use and where. The chainsaw or the automated knife, motorized knife, to carve the turkey. If we want to carve a dinosaur, we probably need much bigger than a chainsaw, but that's a different story. So this is this small example here, short example, and I hope you guys can tell me if you are able to see the font clearly. Ali, can we see the font? Can you see the font clearly?
Yes, we can. We're good.
Okay, thank you. So here's the anatomy of a minimalist program to talk with Olama. You would import, and this is a Python program. We would import the Olama package, which manages the connection to Olama and sending it the chat and so on and so forth. And this is to initialize a direct zero latency local link to Olama. And what you see here is the message being sent to it. The message has a role definition, and when it sees, when the language model sees the user as the role, it understands that this is a question. So we can tell it, hey, what is the capital of France? And again, it's going to go find the word capital, and will look for will list the vector for the word capital in its in the data set that it was fed. And then we'll look in the through the vicinity. So the capital could be close to, could mean financial context, or could be in geographical context. What will determine whether the context is financial or are we talking real estate, are we talking banks, or are we talking geography? What will decide the context is the next token, and the next token it will find is France. So it's going to say, okay, so this user is, it's not going to say that really per se, but practically is looking for the capital of a country that's called France, and according to the tokens stored during the training process of the language model, the capital of France is Paris. And here we are printing the response. So I'm going to open the terminal, okay, to show you the result. So I'm going to run. Okay. So here you go. The capital of France is Paris. Of course, this is a very, very simple example. But what we can do is something a little bit more involved. And that thing that's a little bit more involved includes here defining the persona for we're making the message a little bit more elaborate. So basically, we're setting more roles, and the system role is basically setting the persona for the large language model, which, as you know, from learning how to prompt a language model, you would want to give it a persona. So in this particular case, I'm telling it, I want to ask it about why should I run a large language model locally. And so to set the persona for it, I'm telling it, hey, you are an expert AI engineer giving concise, high impact technical answers. So it will read that and keep that in mind as it spits out the answer. And then this would be the message sent to the language model, and what we will be getting is the answer from it. And in this particular scenario, this program will give you a response in a markdown file. I'm not going to bother you with running it. You will be able to run it when you get the data from the cloud folder. But you can see that Gemma 4 2 billion parameters gave us a very elaborate answer. And of course, we don't take the answers for granted. We have to scrutinize it, and we have to make sure that they are right. But this is the rendering of the markdown file that was generated. It is showing us here the system persona, and you will find that you will understand as you go through the code how everything is working. And here is the response. Here are the high impact reasons for using language models locally. So it's talking about data privacy, low latency, so quick response, cost efficiency, customization and control, and it's even given us a summary table. And this is a concise. Remember, I asked it to give a concise, high impact technical answer. If you told it, give me an extended answer, that answer would be a little different. A third example I wanted to give you to show you how beneficial Gemma 4 2 billion parameter model can be is to ask it to write a plot of a story. And again, here we're saying, we're telling it, hey, you are an accomplished short story author and storyteller. Write a plot of a short story about an engineer who gets lost in a large language model, artificial neural network, and how he found his way back. Sorry for the ladies in here. I was a little bit biased to my gender, and I said he. And one reason why I asked it to make the protagonist a he is to see if the language model will produce will suggest a name for that person and so on. And I asked it to write the file in a actually, I did not ask the language model to write the file. I missed to mention this part. The language models work in is what's called a sandbox. Basically, they cannot access the local system, so they cannot go and change the file system or add files or read files or do any of that. They run like any browser web application runs. It does not have access for security reasons to the local system. So in order for you to write, because I've been writing markdown files, in order for you to write markdown files or read markdown files from the system, you would have to use your operating system commands through the language, the programming language that you use. In this case, we're using Python, and you will see how when you go through the code, how the markdown files are stored. But here is the result of this particular prompt. And like before, we can see it. The plot, the architect of ecos, it actually produced a plot for a story, and I went through it, and the plot is fantastic actually. And I will let you go through it if when you come across this when you study this file. And that brings us to the last and but not least third part of this programming demo. So to be faithful to my own field, I thought, okay, let's ask our 2 billion parameters model to give us a documentation, which in this particular case, by the way, you can use it as a study guide if you want to, about how to fit a line to 3D data and the different approaches. And I asked it to even give me some sample code. So let's look through this. This is the output markdown file, the line fitting. And if we render it, we see here what it's telling us. So the main topic is fitting a line to set of 3D points, an algorithmic and geometric approach, because I told it you're a geometer and a mathematician and a computer scientist all in one. So it talks about, firstly, the algebraic definition and the different algorithms that we can apply and the math behind them, etc., etc. And it gave us some sample code. So again, and sorry to reiterate myself, guys, the 2 billion parameters model is not useless after all, is it? Now to the grand finale that I would like to share with you. And I did it just to give you some ideas for maybe your hackathon. And that example, and by the way, that example, you will find that it's commented to death to help you follow the logic and so on. And I should have mentioned that I used Gemini to help me with a lot of this coding and the code comments and so on. And I hope it will be helpful to you. So this particular program, what it does is it asks Gemma for 2 billion parameter model to analyze the sorry, the novel Les Miserables by Victor Hugo, and to dissect it into 20 different small chapters. Okay, can it do all 20 chapters in one shot? Absolutely not. And I will let you go through the code. And this is one of the reasons why I chose this, because 20 would be huge. It will need a lot of processing RAM space in order to do. So it had to be done in chunks. And please look through the code to find out how did Olama do it. So basically, it created the markdown files, and you can go through each markdown file and read what's going on within that file that is generated by a 2 billion parameter model. Sorry to continue to reiterate. But on top of that, and you will see that in the prompts, I asked it to find links between the different models, between the different chapters. And this is important sometimes because if you are preparing a study guide, you might want to look and see these links. Again, please check the code on how the links are produced. So now we have 20 chapters with links in between them. Then what do we do with them? One thing we can do with them is read them into a note-taking application such as Obsidian. And Obsidian is one of the most used note-taking applications. And you can go to obsidian.md to get it. And here I added all these chapters into Obsidian, which I can view them. And if you remember the links in the MD files, you can go to the next chapter, or you can navigate to the previous chapter, or you can view the relationships between the different chapters in Obsidian. And here we can see, the different chapters and which other chapters are related to it, and how to refer and what is the linkage between them, and so on and so forth. And if you hover, this is Obsidian, over any link, you can see all the links that are attached to it. It's an amazing note-taking tool. Actually, it builds what is now known as a knowledge graph. All right, this is fantastic so far. And hey, yeah, and you can navigate and go to different files from the graph and so on. But that's not all I wanted to show you. What I wanted to show you is another application that we can benefit from in this context. And that application is Notebook LM. Notebook LM is another Google tool that uses Gemini, but it allows you to load sources of knowledge. And these sources can be files, like in this case here. They can be, YouTube videos. They can be anything, or a lot of things. And using these tools, you can generate a lot of things. So, for example, you can generate a movie, and you can prompt it to generate a movie that can teach you. So what you can see here is a video that I generated on Notebook LM using the 20 files that we generated a short while ago using the local LM. So this is a hybrid approach of using a local LM. We use use it to produce our sources, and then we feed the sources to another tool that we can use to make a study guide very interesting. Another tool, another utility you could produce from that are things such as mind maps. I will let you guys go through that, but the one that I would like to focus on is producing a podcast using these resources. And within this podcast, there is a mode that's called the interactive mode. And the interactive mode allows you, the user, as you listen to the podcast, to join the conversation. And I'm going to show you here what happens. And I thought this is very, very cool. I've been using Notebook LM for a long time.
Are you still there? You can't. You went on mute. Dia? Hello? Dia? Okay, so we lost Dia for some reason. Everybody else is still there? Type something in the chat. Yeah, okay, here we go. No worries.
Yes.
Yeah, okay, excellent, excellent. So we'll get him back momentarily. Dia, if you can hear me, we would love to get you back. Otherwise, here's the deal. We are running an additional session tomorrow with the goal of supporting you with skills and learning to help you build things with Gemma. Although the sessions
Sorry, Ali.
no worries,
I'm back.
we have you back. Okay. So I was just announcing something here. Do you have any closing thoughts or?
Yeah,
Yeah.
I ran a little bit longer. Thank you for
No
letting me
worries.
know, Ali.
No, go ahead. Go ahead.
So anyways,
Your
as you can
camera's
see,
off. Your camera's off. Do you want to turn your camera on back on?
let me go to Zoom. Sorry, guys, you can tell I'm not very technology savvy. How to turn the camera on?
We need an AI agent to help turn on camera,
Yeah,
microphone, and
yeah.
stuff like. Okay, no worries. So
All right. So, anyways, so what I was trying to show you are things that you can do with local AI, and either local AI alone, or the a hybrid approach between local and cloud AI. And that's it. This is all I wanted to show. And guys, I would, yeah, before I finish, before I let you go, sorry to take more time. This is the folder I mentioned, and you will find in it today's presentation, and you will find the sample code here. Everything I showed you, including
you're
the
not
the
sharing
folder with the.
your screen is not visible, but I will put the link to the folder in the chat because we have it from earlier. So I'll put that right now in the chat. Yeah,
Okay.
we don't see the screen, but that's fine. So
So anyways, you will find everything in it, and there is a file in the supplementary. I think in the Les Miserables subfolder, there is a file that gives you a link to the notebook LM, to this notebook LM notebook that includes all the stuff I was trying to show you here. So thank you very much, and please don't hesitate to contact me if you have any questions. I'll be very happy to share with you whatever little I know.
So now that brings us to the Q&A portion of this session, and I will ask everybody if you could please type your questions in the chat. There's a okay. I put the link for the next session tomorrow. Novesh, you can just subscribe to it. It's 10 o'clock in the morning tomorrow. Now, in terms of questions for Dia, we will talk about the hackathon later. but there is a question about Kimi 3.0. Do you have any?
I'm sorry?
There's a question about Kimi, Kimi 3.0.
Oh, I heard about it. But I never used it really. There is a lot of hype about it, but then again, as I mentioned, I did not have any experience with it. Some people are saying it's a fantastic language model. I forgot the name of the company, Z, I think. But I really have no clue about it, so have
Okay.
not used it. So.
So there's another question. Trillion parameters require what technology setup to run locally?
I'm sorry, could you say that? I
Oh,
didn't understand.
okay. So I'm reading it from the chat. Trillion parameters requires what technology setup to run locally?
Oh, trillion parameters. You need a huge data center for it, of course. But and that would run locally on a data center that's the
Yeah.
size of Windsor, maybe, or something.
Okay, here we go.
So
Okay, no worries. And then, okay, so Gokul, I will talk about the hackathon momentarily. But right now we're just going to address questions about for Dia. How to use quantized model for Gemma. So maybe can you expand a little bit on the quantized models?
yeah, you just Google where they are and you download them and just run them. They are just language models, but they are compressed.
Okay, so it's another version of Gemma that is quantized, if you will.
They would be an yes. So
Okay.
any given Gemma 4 model or Gemma 3 for that matter, but again, my experience is only with mainly with the Gemma 4. You would find the quantized versions of it. I don't know how to quantize models, but they are available. Different quantizations are available ubiquitously on the internet.
Okay. So, any more questions? Okay, so but with that said, I'm going to share my screen. And first of all, I want to thank Dr. Dialpot for giving us a wonderful presentation. I learned a lot from his talk, and I'm sure others have as well. So we'll just maybe give him a virtual round of applause
Oh, you don't
and
have to,
thank
but thank you
you
very much.
for
Thanks a lot,
all
guys.
the effort that he put together to help us out. So thank you. We got the virtual round of applause. Okay.
I am the one who should applaud you for putting up with this very lengthy
Okay.
presentation, but thanks a lot. I enjoyed it myself. So thanks a lot.
Thank you. And I think we're getting a lot of comments. Okay, so yeah, so there's a question from Prince. Could I integrate Gemma 4 with existing AI applications like Cloud Code and Anti-Gravity?
Yes.
Yes.
The answer is yes. And by the way, let me remind you of the page of Olama where Gemma 4 is listed. So Ali, if you click on models,
Here?
yeah, in the website that you are on, click on models on the left, on the upper left side of the browser.
Uh, Here?
I cannot see your pointer, your mouse pointer. Yes, click on models, please, on the left side, on the far left side, next to the Olama logo.
Okay, I'm not, hold on. I am not opening. You want me to look at the Olama site?
You are on the Olama site in your browser.
Okay, hold on. Let me. Okay, let me do that. Okay.
Just to answer this question,
Okay, here we go.
Yeah, click on models, please,
Models, okay.
and then search by Gemma 4.
Yep.
Click on the Gemma 4 link. It's a hyperlink. So if you click,
Yep.
yeah, thank you. You see the applications section in that page is shows you all the applications you can use with the Gemma 4 model. So Cloud Code, as you mentioned, and Codex, the OpenClaw agents and the Hermes agents, and so on and so forth. So
Okay.
just to answer the question.
It looks like questions are trickling in now. So if you're able to see it in the chat, Dia, it's a question from
Yeah,
Emmanuel.
let me open the chat. I cannot see the
A
chat.
small local. Okay, here I'll read it out. A small.
Okay, I can see the
Yeah, go ahead.
box. Thank you. Sorry, I have a question. This is coming from
Emmanuel.
Damola
Yeah.
Oliyami. As small local models get smarter and context windows grow, do you see hybrid cloud working like becoming temporarily stepping stone? I think, well, let's look at this. The vendors of the frontier models, the huge, humongous models that need little villages uh, of data centers to run, are the same ones that are producing the local models. So they will not put their frontier models out of business, would they? They wouldn't. So frontier models, the huge ones, the 700 billion parameters, and I don't know if there are anything big, if there is anything bigger than 700 billion parameters, they will always remain. They are here to stay. Local language models will serve their purposes, and the huge language models, the frontier models, will still serve their purposes. So let me give you an example from a practical example. If you have a code base of thousands and thousands of files, and if you want to navigate this code base that's say 30 years old, if you want to navigate it to find certain interdependencies between different algorithms, and this is real use case, you couldn't possibly use the local language models. What what you could do is you could subdivide your huge code base into smaller parts, and if you necessarily want to use the local models, and then use the local model to handle these. What I see, what I have been seeing evolving are two things: the local models getting smarter, as you mentioned, and the hardware getting more accessible as well. The hardware that's needed to run larger local models is getting better. So, for example, you can have a machine now that carries 512 gigabytes of unified RAM, the Mac Studio, which, by the way, you cannot find in the market anywhere. Such a machine, because a lot of people are buying those machines, and in the attempt to run, say, 70 billion parameter language models or 120 billion parameter language models for the sake of development. And hence the earlier question about the Kimi language model and similar models that excel in programming. So this is one thing I can see evolving. Again, Notebook LM is a Google tool. Will it disappear? I don't think so. Google Docs are still there, and they have been here for a long time, and they will continue to be there. I hope I answered your question.
Okay. I think yes. Any more questions for Dia? And I think
There is a question from Krishna. Is it not always the rule of thumb that number of parameters define the efficiency? What else could be significant with lesser number of parameters? No, it doesn't define it doesn't necessarily define the efficiency, Krishna. It defines the depth of analysis. Like you've seen, we wanted to find out who is the traitor. If, say, you want to solve a murder mystery, if you want to develop an application that can be used by law enforcement to, say, analyze a crime, okay, you would need a larger, or a language model with larger number of nodes meaning a larger neural network, a very extensive dimension for the coordinates to represent every token, and so on and so forth. And that, depending on your hardware, could be efficient or less efficient. So if you're running, a data center, it will be very, very efficient. You can tell by sending any question to Claude or Gemini or what have you. So the number of nodes will give us better result, more thorough analysis, depending on the problem. So remember, the chainsaw for carving a turkey, you probably don't need it. But if you need a huge turkey to carve, you might need a bigger knife, and so on. I hope I answered your question, Krish.
So, uh,
Could you please share a link for the Google
okay,
Notebook LM? It is in one of the files. You will find it in the supplementary material that I shared via the QR code.
okay. With everybody's permission, I think we just want to be respectful for the Astam and also give an opportunity to talk about the upcoming session tomorrow. So if I know, okay, so yeah, maybe we can just leave it at that for questions for today. And then thank you again for all the effort that you did with the presentation and for answering all.
Thank you very much, everyone. Thanks a lot, everyone.
Okay, so here is the announcement, because I think we want to make sure we squeeze this in before people start dropping off. Okay, here it is. So here is another session tomorrow. We have Arunesh and Joe are going to be giving us a session that is geared towards giving people the additional skills that they can use to build an AI project using Gemma 4. This is tied to a hackathon competition that we are hosting here in Windsor. More details are going to be defined, but the idea is take what you've learned from Dia and his take what you're going to learn from the session by Joe and Arunesh tomorrow, and form a team of up to 5 individuals, build something and submit it. And if you are able to do that, you could win one of 4 prizes of $250 US. It's not going to make you rich, but it's money that you did not have before. Now, this is a local competition, meaning that we do ask that one person from the team is available in Windsor a week from today. So we welcome an opportunity if people want to form teams that are hybrid, where one person is in Windsor and somebody else is in Indiana or India or any other part of the globe. As long as you have one person from the team that is able to be there physically in person representing your project, we would consider that enough to meet the local availability requirements. So that is it. We do encourage everybody on the session right now to just connect with each other and indicate whether or not they want to participate. So I'm going to stop the recording, and I'll also stop the share and